So yeah, as stated, my name is Morten Bilder. I'm here representing the company ARCO, and I'm here to talk with you a little bit about how we are tackling the digital transformation towards autonomy. So by way of quick introduction, for those of you who don't know us that well, ARCO is one of the remaining major global players in the agricultural machinery domain, grown through acquisition over the last 30 years, meaning that we are today a multi-brand company. We also like to think ourselves as being full-line supplier of agricultural machinery, from tractors to implements to self-propelled equipment like combines and sprayers. As a global company, we are, that's a bad picture. As a global company, we are naturally distributed all over the world with both production and engineering facilities in most of the world. In the context of collaboration with DTU, I'm going to zoom in a little bit on my home base, which is our engineering center here in Denmark, more specific in Randers, of all places in the world. What makes this engineering center rather unique, in ARCO at least, is that it is the only engineering facility that is not attached directly to a production facility. Moreover, we are not attached to a specific product line or even a specific brand per se. So because of that freedom, we have over the years kind of developed ourselves to become this more independent entity, focusing on research, advanced engineering, and ultimately technology development to support our different product lines globally. So just like our industry and ARCO by and large are going through this kind of transformation from being a provider of steel and iron to become a provider of technology and solutions, so is the say internal competences and focus area transforming within the engineering group, and in particular within our group here in Randers. So just to illustrate that development in a simple way, I made this chart here showing the growth of our internal resources and competences over the last 10 years, divided between mechanical engineering disciplines and electronic and software as kind of a broad theme. As you can see on the mechanical side of things, things has remained fairly stable over the years, whereas something interesting happened about 5-6 years ago. What happened back then was that we started to approach several Danish universities and kicked off some collaboration, in particular with Aarhus University and with DTU. Shortly after, we also launched our first industrial PhD program with DTU. And only 2 years after that, we were ready to launch the first product generation that was a direct result of this first PhD project. If you want to read more about that specific project, there is a real nice article in the Dynamo from 2018, that is. So with this small example out of many, I can't stress enough how important this collaboration with the universities has been in our transformation. And we really see these collaborations as an enabler to spark and kick off new technology domains. So speaking of new technology domains, the main focus overarching is automation and autonomy, which is what I will dive into now. So before I go too specific about our effort on autonomy, I want to highlight a couple of definitions that we at least work on within ARCO when we talk about autonomy. So we have kind of two objectives within this broad theme. The first and overarching objective talks about smart machinery, which in a nutshell is about automation of our machines, the operations that the machines performs, not only at the machine level, but also as machines collaborate with each other, and as machinery and operations are depending on each other across the whole cropping cycle within arable farming. The other theme talks about driverless vehicles. Now, driverless vehicles, in our mind, is not, it's not the end goal per se. Driverless vehicles is an enabling technology that will allow us to advance the automation to the point where we are capable of talking about redefining the vehicle platforms. So start talking about taking advantage of not necessarily having an operator on each entity, and therefore move towards larger fleets of smaller units. With all of these benefits that I'm sure that you have probably heard of before, so I'm not gonna dive into that. What I find a bit more interesting, to be honest, is not the end destination, it's more the journey. So that roadmap, by and large, we envision looking something like this. So start over here to the left with smart machines, meaning automation of single entities, single machinery, single processes, towards automation of connected machinery, so looking at field operation from more of a system of systems type of approach. This is also where we can start talk about manned vehicles collaborating with unmanned vehicles, still having the unmanned vehicles being supervised by the manned vehicles. And then towards kind of the end game, if you will, fully autonomous fleets. Now, as a company and as a team in Randers also, we are working on all different elements here. So just by way of example, I'm going to give you an example of each of these. First of all, we have our ideal harvest, which is our automation system of our combines, which is really, by the way, what was kicked off with our initial collaboration with DTU back 5-6 years ago. Then, secondly, as we talk about connected machinery, we have an example here with what we call Guide Connect, which allows one tractor to take control over an unmanned tractor. So basically a leader-follower principle. Last but not least, when we talk about full autonomous units, we have our Saver robots, swarm robots, developed for the specific purpose of seeding. As you can imagine, the overall, path as we move forward is to bring more and more advanced machinery, field operations, further and further to the right of this image here. The combine here probably being one of the last pieces of equipment that will make it all the way to the right, just giving the complexity of the machine and of the process. But what does it take to actually bring a machine and a field operation towards automation and towards autonomy? Let's have a look at this example. Just picking on another fairly complicated piece of equipment or field operation, being baling. So consisting of a vehicle system with a high horsepower tractor and a pulled behind large square baler. So today, as an operator of this system, there is a number of tasks that he needs to perform in order to do his job and in order to optimize this task. As we talk about automation, all of these provide opportunities for us to assist the operator with more or less automated systems. All the way from generating optimized route plans, allowing the vehicle to automatically perform these route plans by controlling the speed and the heading of the vehicle, being able to adapt that global route plan to the specific field conditions you are in, to also detect and react to obstacles. And then one of the important pieces is the actual process automation of the task you're performing. In this case, it's producing bales. Last but not least, monitoring and diagnosis of the full system. So all of these technical layers provide opportunities for integration of smart machine features that optimizes or enables the operator to optimize his operation here. As we advance these technologies, we can imagine that we advance them to the point where we can start talking about driverless vehicle. So to the point where we don't need an operator on the vehicle to supervise the operation. He can do that remotely somehow. When we get to that point, there is, of course, also other elements to take into consideration that kind of goes across the whole theme of unmanned or driverless vehicles. Security and safety being one of the bigger problems to tackle. Now, I said that automation, in our view, is not just about a specific vehicle. It's more about the task to perform. And if you talk about a specific field task, there's a lot of decisions, and therefore also optimization and automation opportunities that exist even before you actually go to the field. Kind of high-levelly described here with these decision layers, stretching all the way from the strategic planning of actually investing in equipment or farming practices to performing the tactical planning on when to actually perform a task, to the operational planning on how to actually go about it before you can actually execute the task. So it means that when we talk about automation, we're also focusing on automating and supporting the end user with these decisions. Ultimately looking at kind of a seamless user experience across all of these solutions, all the way from the, say, off-board solutions and technologies, all the way to the vehicle for our more on-board solutions. So, talking about the future is always easy because no one can really argue against you, at least not with evidence, because no one really knows, right? And this is also why trying to predict the future and trying to create this nice vision, blue sky thinking, where we have fully autonomous system and technology is not an obstacle, legislation is not an obstacle, everything is possible. That's the easy piece of it. The challenging piece is to understand and define the next step and the next step on that journey. And that's also the interesting challenge that I see. And one of the reasons that this is a challenge is because of the adoption of technology, especially in our industry, is never happening as fast as we think it will, and definitely not as fast as we as engineers would like it to happen, right? By way of example, we see here auto steering on agricultural machinery took us about 30 years to reach to a full adoption of this technology. One of the obstacles here is that the farmers don't replace his entire system with a new system. Any piece of technology you want to offer him have to fit with his existing system somehow. So he only replace elements and replace with new technology. And that's one of the reasons why the adoption of new technology is happening a lot slower than what we would like it to. This is also why, by and large, what we are really trying to focus on is that while we do try to create these nice vision and these kind of goalposts as a point of orientation of where we are heading technology-wise, we are more focused on taking kind of the incremental or gradual steps, making sure that we bring the customer, bring the end user along on that journey. So by doing so, or to do so, we need to really focus equally on both the technology feasibility of the product that we are trying to bring to the market, as well as the customer desirability. And that really applies whether you talk about a small incremental feature enhancement or you talk about a radical new solution. Only by having a good match between those two, you will have a viable business at the end. Which is also why we as engineers, we need to not only focus on the technology development, we also need to focus a lot more on the product design, making the insights about our customers and the end user as important, if not more important, as the insights about the systems that we are trying to automate in this sense. So with that, I don't know if you have time for questions or.
Well, first of all, thank you very much. I would like to open the floor for questions, if any. Yes, please. If you lift it up and turn it on, yes, you should. There is a button on the top. No, on the top.
Hello, thank you very much for your interesting presentation. I'm a PhD student about to finish actually working in safety and security of autonomous transportation and machinery. We had the small bulldozer in the other venue, and I'm interested in your experience regarding the safety and security of this type of systems and fleet of machinery. In your experience, what has been some of the challenges that you have experienced in terms of safety and security and ensuring that there is not some harmful scenarios that could lead to accidents in this type of system architectures?
Sure, it's quite a big topic, to be honest, but I guess for the moment the main driver is legislation, right? And also to a certain extent lack of legislation and understanding of how legislation applies to our specific domains, which is probably why, for example, mining industries is an area where we see these technology emerge a lot faster, because you can create a controlled environment and you can have kind of safety zones and so on and so forth. We can't do that in our industry. And that's probably the biggest obstacle per se, is that everything we do is out there in the open landscape. We can't put a fence around our fields. So the level of compliance with legislation is a challenge in that regard. Which is also why when we talk about full autonomous vehicles, we do envision that these units have to grow smaller just to be able to implement safety on these machines. Imagine those small saver robots. I mean, they are about this size, right? I mean, if it runs to a ditch, it will just stop, and you can pull it up when you get there. Even if it runs into you, it may make a bruise, but that's about it, right? So it's also about rethinking the shape and form of our vehicles, because Taking the other extreme, take the big combine there. If we are to make the combine as is today run fully autonomously, it will be an endless task.